This is the 2007 oblique collision question. We have a smooth sphere A of mass 4 moving with speed u with the angle alpha here to the line of centers. So the coefficient of restitution is given. Find in terms of u and a speed of each sphere after collision. So let's set up our initial speeds here. So we have sphere A and B. So we have u cos alpha in the I direction plus u sine alpha in the j direction. We have its mass. I'm going to run out of room here, but we have its mass is 4. And we have B, its mass is 8. And it's stationary, so it's 0 in the I plus 0 in the j. And we know with these there's not going to be any change in the j direction, so afterwards, and I'll just maybe write it in here, afterwards we're going to have p in the I direction plus u sine alpha in the j direction for A, and we're going to have q in the I direction plus 0 in the j direction for B. So setting up our equations, we're going to get 4u cos alpha plus 8 times 0 is equal to 4p plus 8q. So dividing by 4, we're going to get u cos alpha is equal to p plus 2q. Then we're going to get p minus q over u cos alpha minus 0 equals minus e. So 2p minus 2q is equal to minus u cos alpha. And from above we have p plus 2q is equal to u cos alpha. Looks like something's going to be 0 here. 3p is equal to 0, so that means that p is equal to 0. So q, what do we have? We have 2q is equal to u cos alpha minus p, well p is 0, so q is just going to be u cos alpha over 2. That's the speed of each after the collision. The angle through which the 4 kilo is deflected as a result of the collision. So the 4 kilo afterwards, we have this p in the I direction, so 0 in the I direction plus u sine alpha in the j direction. So the tan of this, the angle that it's going in, we call this angle B. It's going to be equal to u sine alpha over 0, which is undefined. So if we go back to our diagram, it must be going in this direction here, the right angle. So the angle of deflection is going to be 90 minus alpha. I don't think we have any information to find alpha. And then the loss in kinetic energy due to the collision. So we need to look at our mv squareds, kinetic energy, before and afterwards. So just keep it in line there. So let's look at before. Half mv squared for kinetic energy. So let's look at A. We have a half times 4 times the u squared. So that's 2u squared. And B was at rest. So then afterwards, let's have a look here. Afterwards, we have a half times the 4 times this guy here would be to be the square root of this to be squared. So just the squared part. So u squared sine squared alpha. We would have the square root of 0 to be squared plus u sine a to be squared, but that whole thing is going to be squared anyway, so that will get rid of the square root. So that's going to be 2u squared sine squared alpha for A afterwards. B afterwards is going to be a half times 8 times the square root. Again will cancel, so what have we got? We have q in the I direction plus 0 in the j direction, so it's just this guy to be squared. So that's going to be u squared cos squared alpha over 4, which is equal to the 4's will cancel them, won't they? So it's just going to be u squared cos squared alpha So loss in kinetic energy, it was 2u squared, and we have to take away 2u squared sine squared alpha minus u squared cos squared alpha. So some trig identities here. We definitely have, it looks like we have sine squared and cos squared. We have 2u squared times 1 minus sine squared minus u squared cos squared alpha. So 1 minus sine squared is equal to cos squared, isn't it? Cos, yeah, that definitely cos squared A. Cos squared plus sine squared equals 1, so 1 minus sine squared is cos squared, so we have 2u squared cos squared A minus u squared cos squared A, which is just equal to u squared cos squared A. Are we told to show it's that, the loss in kinetic energy? U squared cos squared